So now let's kick off the section 2. We're going to the section 2 is composed of 3 components. So I'll start from the Aria Pilot Dataset, which is our first open source dataset, and it's really trying to show an example how people can use Aria data. And then we'll talk about tooling and also the Aria research kit as more as an umbrella project for them. So Pierre will talk about it, and then all the data from the Aria, if you download it now, and also if you use the tool and to extract it, it will be in the VRS format. So George will talk about the VRS format in a bigger concept. So let's get started from the Aria Pilot Dataset. So just short introduction. I'm Zhao Yang. I'm a research scientist at Reality Lab Research and in the Sierra team. So I talk about the Aria Pilot Dataset is our first effort to release the public dataset collected by the Project Aria. Okay, good. Yes. So thanks. So particularly for this section, I'll introduce the Aria Pilot Dataset, and first I'll talk about why we want to introduce this Aria Pilot Dataset at all, and so particularly, and I'll go to a few key features that we believe that is very new and even probably give people very different insight about what capabilities of the research you can do in the future. So I'll go through the dataset descriptions and in more details, and so particularly I'll talk about the 2 different scenarios we covered in this dataset, which is one about the everyday activities, and the second is about the desktop activities, which covers the ecosystem of Project Aria that we can enable in the research. And in the end, I will talk about a few examples and just mostly running the state-of-the-art baselines on the Project Aria data. For this part, it's mostly give people a sense that, okay, what you can run maybe today's your algorithm on Project Aria data and what results you might get and what might the new opportunity you can see from there. So so as Richard has indicated, and so why we want to actually introduce the Project Aria and why we want to introduce a dataset for that. So if we're looking at the past existing egocentric research, which maybe in the past decade, and most of the research has been driven by datasets, and most of the dataset has been collected using more like traditional devices. And so on the one hand, you see this more like from the datasets collected by the traditional activity cameras, including the GoPro or some other smart glasses, the first generation of smart glasses, with a feature or two enable either eye tracking or maybe with IMU that can give you a little bit better positional signals, but they are pretty much limited in their sensor suite that what they can enable. So this is basically how the dataset used to be collected. So from the very probably very early effort that making public like GTEA dataset with the gaze tracking over there, all the way to the actually very amazing progress, which from the Ego 4D using a collection of all the different kind of devices with 3,000 hours of videos, which you can now actually to download and do the egocentric vision research. But just as we observe, and these are the more like from the sensing side, they are actually the traditional sensors, and they do have some problems with providing you the rich sensor information that you can do even more ambitious research. So on the other hand, and now we do have some more advanced sensors now, which people do get something right and make it even push into the product side, which you have these mixed reality devices and like the Quest 2 or HoloLens. And so they have a rich sensor suite, but they are not really actually very, from form factor level, they're not very just comfortable to wear and towards an always-on setting. So this actually prohibit people to collect data set and in a natural environment to do the research and study over there. So here is a Project Aria. And so Richard has already introduced the Project Aria, give you an overview. And for the data set, we understand the data is the first way probably to engage a community and people can download and understand it. So this is why we introduced the pilot data set for people to understand and this new concept from the sensing and data you can download and play with now. So just to summarize, what are challenges in the existing egocentric vision data? There's no being captured data from the currently you can download from any public just data sets which can provide the full sensing capabilities that can enable all these features that we believe are super important because we already learned from a lot of literatures in the past that they're all very important for the egocentric research. So you cannot get the per frame eye tracking together with accurate 3D trajectory of a wearer across different activities in the same location. And meanwhile, if you have more actual wearers in the same environment, and you cannot get the sheer space and time information between the multiple wearers. And missing all this information prohibit the researchers actually to really dive into the research to a more futuristic setting, more ambitious way to tackle the contextual AI in a spatial setting. So yeah, so let's talk about more what we have in the pilot dataset. First of all, and all the data being collected using the Project Aria. So if you download the data and all the raw sensor data provided by Project Aria provided a very wide field of view and an RGB camera. And also it has 2 even larger field of view global shutter monocle camera for you to do the positional tracking. And it also have the eye tracking camera. It also have 2 high frequency IMUs and to also help with positional tracking. And it has 7 spatial microphones and for you to record the audios, and so you can do the research in the speech or audio or multimodal research. And in addition, it has various other sensors, which is also important for different kind of research, including the GPS and barometer and also magnetometers, environment sensors. So yeah, in the following talk, you will see actually how researchers use these different sensors in different kind of research. So for this one, I'll just try to focus on the data set and just say what we can provide, and maybe you can use your imagination about what we can do in the future. So besides the comprehensive egocentric sensor suits, which together you collect from the data set, and we also provided the machine perception tool, which is so we run these machine perception tools, and then we generate these machine annotations that you can download together with the data, that you can get this additional information we believe as community, which we understand, and which will be very important for you to do more ambitious research. So this includes the per frame poses, and which give you shared reference frames and across different activities or even across different users. And it all have the timeline sequence information, and for all the recordings have eye tracking, and we provide a full camera calibrations, and for the ones with audios with conversation inside, we provide the speech to text, and for multiple camera, we provide the synchronizations, and all the faces are also blurred out, and to ensure the best privacy. So to cover the different scenarios that Project Aria can demonstrate, we demonstrate 2 different kind of scenarios as we initially indicated. So one is the everyday activities, which is the daily activities the user or multiple user can perform in a day. So there's 143 total of them, which are accumulated to be approximately 8 hours and over 1 million images. And second environment is mostly to demonstrate how Project Aria, not only a single device, but it can play with the existing ecosystem with additional hardware such as the mocap system. And in this way, we can demonstrate that how you can potentially collect further annotations in your research. So there are 16 recordings for these activities, and so just to really precisely measure the trigger aligned frames, there are close to 20,000 images from the Aria which are trigger aligned, and if you include the multi-view images from the additional desktop activities from these multi-view cameras, there are over 200,000 images from them. So now let's go to a little bit deeper into what are these in these activities. So this is a preview of the data set if you download nowadays. So how we record it, and we collected with multiple people and perform different activities, and all this data we first post-process it, and they share the space-time coordinate in one location, and all the recordings have eye tracking, and they have time synchronized speech to text, and also synchronization between multiple variables. So now let's go through each of them one by one to understand it a bit better. So first of all, the activities. And so this is the first effort, and we're trying to get the diversity of different kind of activities right, and also in different locations, but keep it at a minimal amount so that we can keep it at high quality and also help people to understand and release at first notice. So we have a total of 5 scripts, which each of the individual scripts composed of different activities. So in the recording, different activities according to its natural scenarios, it might have 1 or 2 observers at the same time, and they all wear the Project Aria devices recorded. And we record these activities at 5 totally different locations in the United States. And so they give both a bit of a diversity in the activities and also a bit of diversity in the locations. So now let's introduce the first features that we have come together with all the recording, which is high-frequency trajectories for all these recordings. So as been visualized in these videos, and so we replay the activities together with the high-frequency trajectories that we generated for them. So you can see that they are complete time-aligned, and what's more important is that for single variables that performing different activities in their locations, all the activities share the same space information. So all the trajectory are completely aligned in the 3D. And so this is give you the amazing capabilities that you can do the egocentric research, not only as a 2D video, but actually as complete 3D sense, that you can imagine how these different activities in an always-on setting can be associated with the 3D information. So a little bit deeper into the format, and so we call it a high-frequency trajectory format. And so what does that mean? So yeah, different from traditionally people run the visual SLAM that you only get a pose for a particular image or two, and we provided this trajectory in a high-frequency format, which is a 1,000 hertz pose, which is an approximation of a continuous trajectory that you can get over time. So what does it mean is that you not only get the pose you can query for an image or a few more sensors, but you actually can query the pose for any sensor at any frequency. So just being plotted just to show the difference on the right side of the image, and the dot is usually potentially the discrete samples you get for image or something, but actually the pose is a continuous trajectory. So this is probably not very often they're being released in the public data set, but we hope that in this way we can provide the gather location as a continuous format, can give you a different thinking about multimodal research, particularly when you have basically high frequency information from the other sensors like audio and also IMU. So then to get it further, and so you not only get the location for one users, and if there are multiple users in the same environment, they are also being spatially localized in the same environment. So which means that you actually have the different users and doing activities in the same environment, which you can query each other's image pose, and then to get this information completely as a spatial aligned reference. So here's a visualization just to show how this might look like if you have all the different activities in one day. So this shows like more than 40 activities, how they can be actually being merged into the same map. 46 is the largest number of activities you can download from one of our locations, but if you have Project Aria devices, if you collect in your own way, there's really no hard limit how many you can do. And the reality showing the concept that actually have the shared space coordinate system for all the egocentric videos is a cool part of it. And we believe this will be an important part for all the future research in this area. And then to further show it, and so all the videos from multiple variables that not only can be spatial aligned, and then if you can even completely get a time aligned signal for them. So this would really provide you the spatial time reference coordinate. So how to do it? And all you need is just additional time code system, which plug into the Project Aria devices. So the time code system will map the monotonic time from each individual glasses to a shared time system. So which being visualized, what we call here real time. In the nanosecond is the shared timestamp you have here. So what is cool about it is just show as an example which being visualized here. What's cool about it is you not only can get a sense about what's egocentric activities in your observations. In a multiple social activities, actually there's also a third-person view and over there, which is completely time-aligned. So by looking at the literature, I haven't really seen many work or a few work actually really deep dive into this area, but we believe this will potentially kick off some of the new research opportunities for people to understand the egocentric videos, not only as a single egocentric videos, but multiple of them and in a social environment. As we said, all the Project Aria devices have eye tracking camera. So just to really help people to get the most accurate eye tracking information you can potentially get. So we directly provided this eye tracking information already, including the pilot data set. So we use the calibrated information for the eye tracking the sensors, and then we reproject into the RGB sensor stream. So being visualized here, you see the green dot is the user's eye gaze at being visualized device, then reproject it to every single RGB stream. So all the data which you downloaded from the Project Aria Pilot Dataset has this information. And if you have the Project Aria devices, this is also information we can potentially acquire. So this is really probably the first dataset that you can get consistent eye tracking information that really help you to understand the gaze and user interactions and the egocentric recordings, and together with many other information you can get. So, and also in all the recordings, and we keep the audio on. So you do have, when there's a conversation, you do get a speech information. And also just to help people to better use information more conveniently, we run the automatically speech recognition tools and get the tokens, which is the language tokens aligned to the Aria frame, so you can easily query either as a raw audios or the speech and or even just the text information be aligned to the images. So a lot of cool work. We know recently that multimodal research, particularly video, image aligned to the text. So hope this feature can just provide people more convenience and just to dig deeper into this, what's the cool new opportunities over there. So just to highlight, and we are fully committed to privacy, and this is actually one thing we cannot highlight more. So this, for all the videos, and we recorded, and in the everyday activities, and we only hide actors, and there's 0 bystanders in this process, and they sign the consent form, they agree to release, and even that, and we blurred all their faces out. So this is our best effort trying to ensure the privacy, and we believe it's really important as a future practice also for this community as well. Then the second one is the desktop activities. So this is what we're trying to demonstrate a different ecosystem that Project Aria can enable, which if you have additional sensors, usually we see that people use mocap sensor to acquire the additional annotations for objects and hands-on interactions. This is something you can also do with Project Aria devices. So in this visualization, what's being visualized here is that it shows the videos of the trigger-aligned images from both the Aria devices and also the additional or the multi-view videos from a mocap system. And on the right top corner, and you see that the tracking information you can acquire as the additional annotations, and for both the Project Aria devices and also the object you can manipulate in this motion capture system, and even additional information you put additional marker in. So this is just an early demonstration that what might look like if you want to do the research, for example, in the tracking of human or the object and the interaction study of that and what it can enable over there. So in the end, let's just go through a few examples, just quickly, like we quickly run a few of our baselines, just more like showing that you can actually directly plug in your algorithms and get some actually okay results and just without additional efforts. And the first one is detection, and using one of the CVPR detection system called DETER. And the second one was you can actually do so also cool photogrammetry by using the multiple various observations from the egocentric videos, and together with the trajectory and collaborations, and you can download from the pilot dataset. And it's actually you can acquire a pretty good semi-dense map of the environment. And then nowadays you can do even more fancy stuff with NERF. But I think that will be left to all the audiences that you can explore. And the third one is to demonstrate a hand detection, which we all know that interaction will be important. And then you can actually just download the, just apply one of the hand detector maybe from MediaPipe, and it shows that how this hand information can be done not only on the RGB images, but also from the additional monochrome images, which originally been designed for positional tracking, but can also be very useful for additional scene understanding. So yeah, just to conclude, and you can download the dataset today. We released this week, and so here is the scan code. You can scan, and so we really hope that this is as a service examples for you to understand. And so if any questions, any feedbacks, and you have, and just let us know. And we will not we will not stop here, but we really want the engagement from the community to help us understand what people think the priority and also future research should look like.
I have two questions about the data we can get. So first one is like, can you get somehow like a 3D hand pose from like this Project Aria?
Maybe just. So just make sure I understand you correctly. You mean get a hand pose from Project Aria?
Yeah, because like, it looks like there is like two cameras, like a left and right. Then somehow we can like know like a 3D hand pose.
So I was just pretty sure, so this is possible. So we didn't provide it in the downloaded data set. So just set up some connections here, like the monochrome camera you get is very similar to the Quest setup. So there are actually kind of similar settings you can get hand pose. And so we haven't provided yet, but I believe as we show in the initial demo, you can probably use some existing open source tool, can also get some decent results just for your usage. Yeah, but to really ace that, to really solve that problem, it might be additional research.
Yes.
So you can probably do. Yeah.
Yeah, thank you for answering. Then my second question is, you showed like an eye gaze on the images, videos, and I wonder like how you project like an eye gaze on the image, because probably we don't know like exact distance that where we see on the scene. In that case, it's quite limited how we project on the image because our eye position and then like camera position is different. So yeah, how did you deal with that?
Yeah, so it's actually a very good question. So it's probably part of the motivations why we directly provided you the already reprojected RGB eye gaze information for you to really save you from all this trouble to understand all the details to get all the things right. So first of all, you need very good user calibrations during the collection so that you can get actually the good calibration to basically tailor to some of the calibration to the users. And second, and you do need understand, this actually the information is public, which you can extract from the VRS file. You get the eye tracking information, but all the calibrations, the basic extrinsic of the eye tracking cameras and their reference frames and all the stuff, which is being defined in which if you run it and define your coordinate system right, and you will get an eye tracking results as a vector, which is being defined in some coordinate system, and which is also in 3D, which you can get it. So, but you still need to do some processing to really reproject it into the other sensors, which usually for usage. So we basically kind of just do all this stuff already. So basically all the things we provided is already reprojected to the eye tracking, which is kind of like, oh, well, it's already the eye tracking information reproject to the RGB image overlaid. So it's kind of like the way how usually people use it. So we just think that providing it will maybe more convenient for you and to use eye tracking information. Yeah.
So like we can still access, for example, like the initial like 3D vector of eye gaze. Is that right? Or we only have we can only access data on the like 2D space.
So the information being released is already reprojected in the 2D space,
So we only can
overlaid it on the RGB camera stream.
Mm-hmm.
You can run your own eye tracking, whatever algorithms you find your own, and to process information based on the raw data which already released together in the VRS format. But you may lack some of the key calibration information to really get as accurate as we provided. So so it's really, I would just say, if you really want to do eye tracking research, probably maybe contact us. And so we may have a few contact points so we can really help you. But if you just say you want to use eye gaze for all the kind of vision research, all the recordings we released have the eye tracking information for all the basically raw stream. There's no even dropped frame of eye tracking. They all the eye tracking timestamp and all the eye tracking information already been processed in a calibrated way. So this is the most accurate we can guarantee to ensure that you can use now. Yeah.
Yeah, thank you so much for your detailed information. Thank you.
Hey, Prince.
Hey.
Hey, a couple of questions. So do we allow controlling the camera auto exposure gains, or are they kind of hard-coded?
So all the exposure informations are also already in the VRS information in the VRS, so you can access that. And so there's actually even more information, even including some kind of maybe temperature or this. But this like if you just download the VRS and then you can actually we didn't hide anything. So basically everything with a device which from the form factor, which like from our side we can write as raw data is all there. Yeah.
And do you capture Wi-Fi and GPS? Also,
Yes.
the streams for that?
So just to clarify, the pilot dataset, we use a particular profile that in the indoor that it's currently doesn't actually have the Wi-Fi, GPS, all the information. But as so So basically, a short thing like we will release some of the outdoor captures, so that will have actually more of the GPS information.
Right.
So and also, if you get a Project Aria devices, as PL talk about, there are different recording profile you can choose. And for the full sensors, you can enable Wi-Fi and like barometer and additional sensors that you need. Yeah.
Okay. One last question. So does the device flex? Do you have like calibration changing, extrinsics changing over time? And so do you somehow capture that, or is that something that the VIO algorithm needs to do?
So you mean the so I'm trying to understand your question correct. You mean
So that the device can flex, right?
Yeah,
So
yeah.
the cameras can move, IMU can move with respect to each other. So do you track that over time, how that has changed? Like if I wear it versus somebody else wears it, it's going to have a different flex.
Yes. So actually, the from the raw also is same in the raw VIS file, which means recorded. So each device, according to its different size and different specs, they have the calibration information. Just to clarify. Okay, Gene might have some more details
Okay.
here. Yeah.
Oh, yeah, so we track that, which all the trajectory we generated are counted all these deformations online.
Okay.
But unfortunately, we have not exported that.
Okay.
So we do not express this like, it's actually dynamic tracked, but right now only exports a static calibration. Exporting this dynamic calibration will be some of the future work.
Okay, sounds good. Thank you.
Yeah, and if you do get access to the Aria Research Kit, in there are machine perception services so that you can generate the VIO trajectory out of it, which will take that into account.
Okay, thanks.
Hi, thanks for the presentation. 2 questions, please. First question, is there any easy way to synchronize the device with some other device, like 2 glass devices or third-party equipment?
So basically, just to summarize what happened behind the 2 different ecosystems we demonstrated. So one, the Project Aria device, 2 Project Aria device sync, that was just using the industry standard timecode system. So basically, as long as your additional devices can work with timecode system, for example, GoPro, which I have worked before, that's the same system. As long as you set up the channels and all the settings right, it should be possible. But you need some attempts to just basically do it. But the mechanism is that the other one, which in the desktop scenarios, they are trying to ensure they are trigger aligned, which basically is not only that you are mapping to a time system, you actually need to trigger each individual camera. That requires quite some effort. So currently we are just releasing as a data set to demonstrate this, but it's to providing this kind of support and further guidance. I would say we will do it in the future work, but currently there are actually a lot of details over there. I'll try to get it right and to provide support for the OCDEM users.
Okay,
Yeah.
I'm referring to like external collaborators or something, not in-house. So collaborators, can they sync the device with something, or this can happen only in-house?
So my suggestion is still just contact us and then just maybe write a proposal for a very short paragraph about what you want to do, and we will discuss it. And then, so basically the research program is pretty much open, so we can adapt the need really according to people's interest, and then there are a lot of them where we can support. So this is something we can discuss. Yeah.
Okay, and one more question for the dataset. You capture 6D poses for the objects. Do you also provide meshes for the objects or not?
Also a short notice for future. So Linyi is the the primary driver for that data set, and then we will have the future. So basically, all the data set you see here, some of them are actually a YCB object, which is already we use a YCB object already to have the meshes. So we do have intention to release more in the future, and just really for particular research in object tracking with more 3D object launches. Yeah.
Okay, thank you.